Okay, we're going to talk a little bit about how to interpret graphs of proportional relationships. So our proportional relationships so far, we've looked at them having a constant rate of change. The line that's created has a pattern. We call that pattern a slope. There are a few more things over the course of the unit that you'll learn that make these proportional, but we're going to take a minute and look at how this all fits into some real world situations. Okay, so read along with me. Mary's class is having a holiday party, and she is in charge of bringing juice. She decides to bring powdered juice mix and add water at school. The graph shows the proportional relationship between the volume of the water Mary uses to make the juice, that's X, and the number of scoops of juice, Y. So my X is the amount of water, okay, this is our X axis, and the number of scoops is our Y. Okay, and they even tell you that in the description and they show you on the graph. Okay, so what we're looking at in our graph here is how many scoops compared to how many liters. It's kind of like if you've ever made Kool-Aid at home or the lemonade in the mix. You have a certain amount of scoops and a certain amount of water is the recipe. So what we want to know is, what does the point 4,8 represent? And it's plotted right here. So each point on this line represents something in this situation. We specifically want to know, what does this point mean? Okay, the point is 4,8. 4 liters, 8 scoops. This means that for 4 liters of water, she needs 8 scoops. So for 4 liters of water, she needs 8 scoops. Okay, if we look at some other points, for 0 liters of water, 0 scoops. Makes sense. Now, 1 scoop is, I don't really know how much exactly that is because it's not where grid lines cross. But if I look here, my grid lines cross at integers. So 1 liter is 2 scoops. 4 scoops is 2 liters. Okay, and you can see the pattern. If I did a rise over run, it would be 2 scoops for every 1 liter, right? If I made a big triangle, it's 8 scoops for every 4 liters, right? So we're just looking at the situation, figuring out the pattern, and deciding what those numbers represent. Let's look at another. Belle is hooked on a new book series, The Galaxy. Each book in the series is the same length and chronicles a different year in the Waka Waka Galaxy. The graph shows the proportional relationship between the number of books on the shelf and how much space they take up. Okay, so knowing that they're all the same length, this girl is so into it that she wants to buy a bookcase to fit her books perfectly. Okay, some of you will be able to relate to that totally. Others will not understand why someone would want to do that. But either way, Belle is crazy about these books. She wants to have all of them fit in her bookshelf. So the graph shows the proportional relationship between the number of books on the shelf, X, so here are our books on the shelf, and how much space they take up, Y. Okay. So before we get to the question, let's look and see what's happening here. If she has no books, she needs no space, right? If she has 2 books, she needs 1 inch. If she has 4 books, she needs 2 inches. Now, I know I say to always look where the grid lines meet, so that you have integers. But if we look at the situation, you can probably guess if she needs 1 inch for 2 books and 2 inches for 4 books, guess how much she probably needs for 3? 1.5, right? So once we recognize the pattern, let's take a look at what they want to know. They want to know, what does 10,5 represent? Well, 10 means 10 books, 5 inches. So she needs 5 inches for 10 books. That's how much space she needs on her bookshelf if she wants to put 10 books there. So how much space does each book take up? Each book takes up half an inch. All right, next one. Eli wants to fill his water bottle between classes, but the water fountain next to his classroom is frustratingly slow. The graph shows the proportional relationship between the amount of water in ounces he puts in his water bottle, so there's our x coordinate, and how long in seconds it takes to get that amount, y. What does the point A represent? Okay, so let's look at, before we start figuring out what A represents, let's just take a look at the situation of what's happening here. So y is how many seconds it takes to fill. X is how many ounces he gets. Just so you have an idea, usually a soda or a bottled water is about 16 ounces. Well, no, let me see. Yeah, a water bottle is about 16 ounces. I think a soda is maybe 12. So just so you can kind of have a frame of reference when looking at these ounces. So 2 ounces is not a lot. Okay, 2 ounces is like a teeny tiny little Dixie cup. Okay, so what does A represent? Well, that my x coordinate is 2 and my y coordinate is 20. 2 is the ounces, 20 is the seconds, right? So it takes 20 seconds to fill 2 ounces. That's what's happening here. It takes 20 seconds to fill 2 ounces of water. And if you look at my other integer coordinates, it would take 10 seconds for 1 ounce, which makes sense in the pattern. And of course, if he had 0 ounces of water, it takes 0 seconds. So you're just looking at the situation, reminding yourself what the x and the y represent, and making sense of the different points of the situation and the pattern. That's it.